Good morning, everyone. Thank you for joining us today for our next user group meeting for the Modicon user group. Today, we're going to talk about how to integrate Ethernet switches into an automation system. Curiously, many customers do not do this, and it's a critical part of their automation platform. So joining me today is Jerry Bartolome and Robert Willis. They are our senior SAEs, our architect experts. My name is Lou Arone. I lead our SAE team across the US, and I'm hosting you today from sunny Southern California, which is nothing but rainy and cloudy and cold. So, but anyway, so let's join. Today, Modicon user group, these are our subjects that we normally focus on. Today is around networking and keeping you connected. This is a typical network that you may see where your PLC is connected to multiple switches that are out there. But again, in a lot of cases, many customers are not connecting and getting the health and status data from your switch. So we thought it was a good idea to maybe show you how easy that is to get and what kind of data and what you can alarm on. So yeah, so that's what we're going to focus on today. Before we start, a couple of different things. One is I wanted an exciting announcement. We created a Modicon user group YouTube playlist. My team puts together videos. Schneider Electric puts together videos that are focused around those topics, the PLC topics, networks, next generation automation, VFDs, and we want to share that information with you in a very easy a one-click location. So we're posting a lot of these. I'll put this link into the chat, and that is for that playlist. And feel free to go out there and browse our videos. And our videos are only about making our stuff easier to use. So please take a look at that, and I'll put it in the chat. Speaking of the chat, a couple of things to note during our video today, or our webinar today. There's a chat window, and then there also is a Q&A window. Please use, for all questions, please put it into the Q&A. A Q&A kind of keeps the questions and the answers together as a group, whereas the chat is more of, everybody knows what a chat is. It's kind of a linear progression of a conversation, a little more difficult to follow and answer questions on. So again, please direct your questions to the chat, excuse me, to the Q&A. We have people standing by to answer those. And with that, I'm going to pass it off to Robert Willis. Robert?
All right. Thank you, Lou. I am having some technical difficulty getting my screen to share. There we go. All right. My name's Robert Willis. Both myself and Jerry Bartolome will be doing this presentation, so I'm actually going to turn it over to Jerry for the first part, and I will finish up with the active demo and the final part of the presentation. So Jerry, I'm going to turn it over to you. Jerry?
Jerry, you're on mute. All right, Robert.
Okay, we'll wait. We'll go ahead and get started. We'll let Jerry join in. So what we're going to talk about today is the Modicon switch overview. We're going to give you a little bit of highlights into the switch and how we actually integrate that into a Modicon system or to a SCADA system so you can capture data. And we're going to start off by just coming up with a quick overview of what a unmanaged switch is, in case you are not aware of that. Then we're going to move into the managed switch. We're going to talk about how you configure the managed switch into your system, and HTML5 web interface. We're going to talk about the industrial protocols, and we're going to have an online demo. And as Lou pointed out, anytime during the presentation, if you have questions, please put them in the Q&A, and somebody will get an answer to you promptly.
Robert, I have my microphone back, it looks like, so sorry
All
about
right,
that.
so I'm going to turn it back over to Mr. Jerry Bartlemay, and he's going to handle the Monacon unmanaged switch and go from there. Jerry, it's your
We'll start
ball.
with the unmanaged switch. Yes, sir. Go ahead and switch. There we go. So unmanaged switches. So they're, like the slide says, is for basic connectivity. A switch is, unmanaged switch is basically a connection device. It has no managed properties. You can't even assign it an IP address. And so it is, it's really used more in local environments where you need to connect multiple devices together. We don't recommend it for use in, say, a backbone, where you need more configurable properties. You need to be able to monitor the health of that, those switches, and be able to do some filtering and have some cybersecurity features, those kinds of things that are not offered by an unmanaged switch. However, an unmanaged switch, especially as a very inexpensive connection device, is basically just a tool to get multiple devices connected together. Go ahead and switch the screen, Robert. All right, so here's our unmanaged switch offering. We start with a 5-port all copper switch, and we have an 8-port copper switch. We have several switches with fiber ports added to them as well. Now these fiber ports and the copper ports, because they're unmanaged switches, they don't support ring protocols or anything like that, but they're very useful for extending the range out to a farther location by fiber, or extending the range through an area where you need a high degree of electrical immunity, because you've got a lot of electrical noise going on. So fiber is very useful for those kind of purposes. So yeah, go ahead and switch. Let's talk about the managed switches now. There are a couple of different types of managed switches that we have, but they all have a lot of things in common. So they all really have these 3 classes of functions. The diagnostic functions, the ability to go in and see what ports are being used, enable and disable ports. Port mirroring is a very important diagnostic function. It allows us to connect a PC and monitor the traffic on a different port. And so if you're using Wireshark to diagnose what's going on in your communication system, port mirroring is necessary to give your PC access to those messages, because a switch, by definition almost, and its key function is to route messages between ports only where those messages need to go, and not involve the other ports. So I see a question up there: what power do the unmanaged switches require? All of these switches are 24-volt DC powered. The managed switches support redundant power supplies as well. From a security standpoint, we've got a number of different things in here. This is a pretty short list of security features. So the filtering, the login authentication for logging into the switch itself, monitoring port traffic, and the ability to enable and disable ports is pretty important. From a management function standpoint, holy cow, as any good managed switch out there, you need to be able to configure virtual LANs or virtual local area networks, manage broadcast traffic through various means, support redundancy. So, switch redundancy can be very important in a high availability architecture. A switch can be a single point of failure in an automation system, and by supporting redundancy, that means that we can remove that element as a single point of failure. Go ahead and switch screens, Robert. So the Monacon managed switch, and I'll just say, if you're familiar with our switch line, the previous generation of switches was referred to as Connexium. Now the name Monacon is part of a consolidation of family names that we made to reduce the number of total family names. So Connexium was brought into Monacon. Things like our distributed I/O platforms were brought into Monacon, and consolidating things around the PLC and PAC line that we have. Just so you know, and it's no secret out there, The Modicon switch line is a Hirschman product. It's brand labeled by Hirschman. We have a long relationship with Hirschman. They've provided the last 3 generations of switches for us. They're a very well-respected switch and router manufacturer out there. And because we use Hirschman, we only provide layer 2 switches. We don't provide layer 3 switches or routers, that type of thing. Hirschman has a full line of those for the industrial market. And so anything that is in the Modicon switch line is fully compatible with anything in the Hirschman line, including the use of like HyperRing, which is a Hirschman proprietary ring protocol with very high performance. But some of the newer features of this latest switch line, we've improved the cybersecurity aspects of it. So improved denial of service, response and prevention, access control lists. We've got local role-based user management, which we've not had previously. We've added redundancy features. So more redundancy protocols are available to fit into whatever your needs are as an end user and whatever your preferences are for those type of protocols. There is a harsh version of these switches out there. So it's conformally coded, and on the PoE or Power over Ethernet variant, their device that we have, it has an extended temperature range as well. So instead of 0 to 60, it's a 0 to 70 degree temperature range. We've added a digital input. So SNMP traps, simple network management protocol. That trap there is the switch monitoring conditions in traffic and in itself, and sending a message up to an SNMP manager software, which is typically how IT departments, at least at a low level, manage and monitor their switches, the health of those switches and the activity on them. And so now you actually can have an external means, for example, panel access. That could be on a levitt switch on a door and send an SNMP trap based on somebody opening the network cabinet. So that can be very important from a security standpoint, and it can be important for other reasons, depending on how you use that input. We now have gone to a USB-C interface, so it's more universally accepted today, and it's kind of looking towards the future for the connection cables and for the connectivity features of USB-C over previous USB connections. And we've migrated away from Java on the web interface, and we're now supporting HTML5. So that makes it much easier to support getting away from Java and its quirks and peculiarities when it comes to versioning and that type of thing, not to mention security aspects of it. So you may have noticed a few acronyms on here. So you'll have access to the slides through the Modicon Users Group portal. And in the notes for these slides, there are some acronym definitions in there. So anything I mention, I will try and state what that's for, but look to those slides for more definitions. And of course, Google works too if you're trying to figure out what some of this stuff is. All of this information is found in the Modicon Networking Catalog. And so there's a link to that in the notes on the first slide. And then you can also just go to se.com and in the search bar, type in Modicon Networking Catalog. It will take you right to that document. All right, so here's a comparison of the previous generation, the TCS part numbers versus the MCS part numbers, the current generation Modicon switches. So you can see right off the bat, from a environmental standpoint, we've gone from an IP20, which is finger safe, to an IP30, which allows even blocks, even smaller pieces, parts, devices, tools, and whatnot from getting inside the switch inadvertently. A number of different switching and redundancy enhancements here. We did a lot in the cybersecurity aspect, and which is real important. And then we've, from a diagnostic standpoint, We've given enhanced the port monitoring. We now have an audit trail that can be implemented, and full MIB support. The MIB is a management information base, and that's basically a definition of the information that can be gotten through SNMP from that switch itself. All right, go ahead and switch over. All right, so we've got a number of different new references here. The most recent additions to this line are the high port count switches. So several of these have SFP sockets, and several of them support gigabit networking. So the first one on the left there, that's all copper. You've got 10 100 TX ports, and then you have 4 gigabit ports, all full duplex ports. Then we have a 1600 megabit variety. The next two are 16 or 2000 megabit ports with 4 SFP sockets. So SFP, if you're not familiar with it, is a modular networking tool. So basically those are sockets that accept little modules. Those could be copper and 100 megabit or gigabit or single mode, multi-mode fiber. There is even SFPs out there that will accept both multi-mode and single mode. I'm not sure how they do that, but they do. And so those are very, very flexible switches and very suitable for backbone use, especially with the trend toward gigabit backbones. The ones on the right, the DRS, those are the dual ring switches. Those support a second ring or a sub ring of RSTP, which is suitable for use with our Ethernet remote I/O system. And so if you need a switch in the Ethernet remote I/O system, one of these 3 switches are the ones to use in there. They have special configurations in there that allow them to maintain the integrity of the remote I/O system and to perform and maintain the determinism of that system as well. And one of the key things is that if you have a break in a cable somewhere, that you have the ability to recover quickly from that. And so these switches, just like the drop adapters in the remote I/O system, when they're used in there, will ensure recovery even in a full 31 drops of less than 50 milliseconds. So the I/O won't see a blip in there. That's a short enough time where the I/O will just keep running. And so it was very important to us to get the new feature set into the DRS line as well. So those are available either in standard or in hardened versions. Okay, Robert, go ahead and switch. So in dealing with switches, especially the more sophisticated the switch, the more settings you have available for it. Robert's going to go into detail on some of that in his part of the presentation. So we're dealing with electricians and instrument techs and things like that out in the real world in the process environment, not IT professionals. And so if a switch fails, how do you have that person reconfigure that switch if that person is not, he or she is not an IT literate person? And so the easiest way to do that is to use a memory backup adapter, the EAM. And so that plugs into the USB-C port. It has a little screw on it that secures it in that port so it can't just fall out. USB-C, of course, by itself doesn't have any means of securing it in the port. And through the web interface, then you can store the configuration to that memory module. Now, if you have a switch failure, you take that memory module out of the switch that failed, replace the switch, plug it into the new switch, power the switch up, and it will read the configuration from that backup adapter. So it's a very, very simple switch over. So this is similar to the like fast device replacement on one of our VFDs connected to a controller. It's just the one-step switch over that anyone can do who is capable of turning the screws and replacing that switch. Go ahead, Robert. All right, so here's the switch family that we offer, the full switch family. So the ones I mentioned previously, those are the ones up on the top. Those are the high density switches. But yeah, we offer switches in the standard managed line from four ports with additional fiber to 8 ports with additional fiber. The PoE is an 8-port switch, supports gigabit, and PoE is power over Ethernet. So they could power a camera, they could power an instrument or field device over the Ethernet cable. PoE is interesting. You know, Ethernet only uses 2 of the 4 wires in an 4 of the 8 wires in an Ethernet cable, and so the other spare wires are used for power connection to a field device in this case. So these will under 60 degrees C, these will provide 90 watts total of power to field devices, and 60 watts if the temperature is over 60 C. All right, and then we have our dual ring switches, or what we call extended managed switches, on the right. I think we have some other questions here. Can we configure the switch via configuration file from a PLC or IPC? I think Robert's going to cover that. XML or EDS when he gets to his part. They do not need Java to configure. They're programmed in HTML5 now, so we've moved away from Java. So the switches are, the main switches are very much like the Hirschman product. So in fact, there is a crossover for them. If you have a favorite Hirschman switch you've used and you want to use the Modicon switches because it's in a Modicon system and you'd like it all to be purchased and supported by one manufacturer, then yeah, we have the equivalent switch for those. Hirschman does have switches, especially up in the layer 3 realm, that we do not carry. And so we're fully compatible with those, but we do not offer the entire Hirschman line. We do the bulk of it, and it's actually, in my experience, pretty rare that we need something unless it's a layer 3 switch above and beyond what we can offer. The dual ring switches are the exception to that. So those are custom configurations made for us specifically for the Ethernet remote I/O environment. And so there is not a Hirschman direct equivalent for those. All of these switches are available now. The dual ring switches were the last that were released. Those hit our system on the 20th of last month. So it's been about a little over a week here since those were in the system.
All right, Jerry, thanks for answering those questions for us.
Yep,
I'm going to get into how we actually configure the switch. Heard some questions in the Q&A on, can we do it with XML? The switches are configured via the web page or the command line interface. The most preferred method that I view is the web interface. It's more intuitive to you, which you'll see. But how do we get the switch when we first start out? How do we give it an IP address? We use a tool called the Ethernet Switch Configurator. When you run this tool on your computer, excuse me, you're going to select a network adapter that's connected to the same network that the switches are on. And the Ethernet Switch Configurator is going to go out there and find every one of the Modicon Ethernet switches. Now, it's only able to find them if you have not gone into the web page and turned off that ability. So once you get it configured, I can come in and say, I don't want anybody to have the ability to scan my network and see all of the switches. As you see on the screen here, it's bringing up 2 switches that I have on the system. It gives you the part number, the product name, the current IP address and net mask and default gateway, as well as the MAC address. Also indicating that it's writable, meaning that I'm not blocking it. From there, I can go in and select an individual switch and then modify the name, the IP addresses you see. On the right-hand side, you're going to see I've saved it 192.168.0.103, and I put in a net mask. Highly recommend you put in a default gateway, but in this example, they didn't do it. And once you click OK, it will save this information to the switch. So now, once you have that IP address, we can then go into the Managed Ethernet Switch webpage. And as Jerry pointed out, this is HTML5. We do not require Java, and it will work with most current HTML5 browsers, if you will. Edge, Firefox, Chrome as an example. You're going to log into the switch. Because we've tightened the security, you're going to put in HTTPS. It will not accept an HTTP connection, so it's going to do a secure connection. We're going to type in the username and password, and the username for the switch is admin, and then the default password is private. You are going to have to change that the very first time you log into the switch. So once you log into the switch, you're going to get the very first page that comes up. It's going to provide you the diagnostics of the switch, the port status, the system name, the power supply, things that you see here on the screen. And I can come in here and start configuring the switch. If I am the administrator, I can make some changes. I'm not going to go through all of the web pages. We're just going to highlight some of the key ones that you might deal with. How do we save the configuration? You've made all of your changes. As Jerry pointed out, we're going to save the configuration. We can save it in the non-volatile memory of the switch. But if I need to replace the switch, I'm going to use that external memory and store it to the USB connection on the front. That way, if I replace the switch, put that USB memory stick into the new switch, power it up, and it will reload your existing configuration. So how do we get in? Today, we're going to talk about the protocols. When I get into the actual switch, I'll go through some of the other screens. So how do we take our Modicon switches and allow you to bring the data from the switch into, say, a Modicon M580, into a SCADA system such as a Viva system platform, or another SCADA system using Modbus TCP IP or Ethernet IP protocol? But the switch, the Modicon switches, they support 3 protocols. On the left-hand side, the industrial protocols that we support are IEC 61850 MMS, Modbus TCP IP, and Ethernet IP. Basically, what you do is you turn on the protocol, you allow or disallow write access, and you make a determination of how many active sessions do you want to allow. The IEC 61850 is manufacturing message specification. Primarily see it in the utility industry, intelligent electronic devices. We see it in RTUs. We see it in SCADA, a lot in the substations. So that's where that protocol is utilized. But the most common one for the industry, if you will, would be Modbus TCP IP. It's simply a Modbus RTU protocol with a TCP IP interface. It's been well documented. You go in, you turn it on, you have write access. We define the port. Now, the standard port is port 502. If you wanted to, you could change the port, but now every standard Modbus TCP IP device you have, you're probably going to have to go in and change its configuration to allow communication on a different port. Just like in the other protocol, we're going to set the maximum number of sessions. And the last protocol is Ethernet IP. Now, Ethernet IP, the IP part stands for Industrial Protocol, and it adapts the common industrial protocol of CIP, if you will, to Ethernet. Well utilized protocol in the industry. It's an open source, open standard. Both suppliers and vendors can design devices to take advantage of Ethernet IP. So we're going to go in and set the VLAN ID of how we want it to operate. And now what I'm going to do is go to a live demo. So I'm going to close down my PowerPoint, if you will, and now I'm going to bring up my live demo here and bring this to full screen mode. And so now in the live demo, and then I'm going to go to the web pages, but in the live demo, I have a Modicon M580 PLC, and I want to read information from two switches that are on my network. They were identified in the drawing that Lou Arone showed as SCADA SW1 and SCADA SW2. What I'm going to do is show you the data that we can pull out of the switch, and then I'm going to go back and show you how we did it. So the SCADA Ethernet switches, if you play it around with Modicon M580 and EcoStruxure Control Expert, this right here is the data coming in from the Ethernet IP switch. And here I have my, well, it would help if I connect to my PLC. Okay, I'm communicating to the switch. The communication is valid and the freshness of the object is valid. So Ethernet IP, when I click on this switch 1 input, I now have all of the information that you see here, everything from a security, the power supply errors. I do not have a second power supply hooked up to the switch, so it's telling me there's a problem. I'm not overheated. The USB stick drive has not been removed. If it was there and it was removed, it would tell you. And here I have the parallel redundancy rapid spanning tree telling me if it's enabled or disabled. And now I'm going to come down here and look at link status. This double word looks at all switch ports. And as Jerry pointed out, we have some high count switch ports, 24 ports. So starting on the right hand side, this is port 1, port 2, port 3, port 4, all the way over. And I have a 10-port switch, and almost all of those ports are configured. The first 2 ports on this 10-port switch are fiber optic, and I do not have a fiber optic cable. I have one multicast connection to the switch, and I have no TCP/IP connections to this particular switch. So this data, just by telling me where the switch was, in utilizing the EDS file, the electronic data file, I'm able to bring this information into the PLC. The second switch, we're going to use Modbus TCP/IP, and in Modbus TCP/IP, in the information, it's going to come in here and tell you that what Modbus register. So I'm reading 64 registers out of this switch. Just like before, I am reading the switch. And here's my inputs, and the 64 inputs that I'm bringing in are related to the port status. So as you can see, port 0, port 1, port 2, and here is my port 3 status and port 4. What I'm going to do here is I'm going to break the cable from that port. You're going to see that the port reported that it is faulty. That information could be used in your application to modify the way the system is operating and maybe take an alternative path. As Jerry pointed out, with redundancy, maybe it might go an alternative path communication. And I'm going to plug it back in, and it's going to automatically update. Now, because I'm reading Modbus registers, I chose in this demo just to read the 64 inputs as an int, and then I chose to do something called alias. So I created a tag called SCADA_SW2_port1_status. And I can use this alias in my program, and I don't have to have just this data right here, okay? The Modbus registers that are in there are documented in the installation manual. And that installation manual has information about all of the, I'm sorry, it should have been not the installation manual, but the configuration manual. If you go down to the industrial protocols, you go down to Modbus TCP/IP, and in Modbus TCP/IP, it's going to give you a complete listing of all of the registers that are in this switch. The very first grouping of registers talks about the port type, and you would decode that register based on this. The second grouping of registers talks about the link status, and that is F1, and it's just a 16-bit unsigned integer, and so forth and so on. So the next thing is STP status. So depending on what you want it to monitor, I'm going to pick the appropriate Modbus register. With Ethernet IP, we have defined an EDS file that brings back a lot of information. But if you want more information on Ethernet IP, we can go to that standard. And now in the manual, it talks about all the attributes that we have available to you that you can bring into the Modicon M580. And this is an entire listing. They talk about objects, they talk about the interface object, the capability. So you can see I can read a wealth of information. So the information you bring into the Modicon M580 might be a subset. It's only what I need in order to manage the application. While a SCADA system comes in and gathers additional information that it might want to present to the user, and an SNMP device can go in and gather some additional information specifically to the network. So I'm not limited to just one device talking to me. So this is in here. As Jerry pointed out, you can download these manuals from the same page you get the catalog from and go from there. Any questions? And Jerry, I'm not seeing the Q&A on mine, so if there's any questions coming up, I would like to have you answer them if you would.
So Robert, there is a question right here. It says, can Robert indicate how he's getting the Modbus TCP data into the program? Does Schneider Electric provide a pre-built DFB for this comms? Is he using the IO scanner? Is he using Modbus Plus MSTR block?
Okay, I like the question because that's exactly what I was going to show you next. So we are using the IO scanner, and I'm IO scanning off of a NOC module. And in that configuration of the IO scanner, I have both a Modbus connection. So here's my Modbus. I'm going to come down here and give it a variable name of my choice. That's the prefix. I'm going to go to the address setting and tell it what IP address that switch is. But here's the answer to your question. I have a request, and in here I am reading 64 words. I'm not doing any writing. I'm reading 64 words starting at address 10088. That's 41,088. I'm reading it every 120 milliseconds. And I have a timeout that says, if I don't respond in 120 milliseconds, I'm going to do a health timeout and restart. Now, this data is coming in a raw form. I'm bringing in 64 words of data in an int form. Your question was, do we have a DFB for the Modicon M580 switch? Not at this time. We're bringing it in as raw data. Reason being, if you remember looking at that complete Modbus list, how much of that data do you want to bring in? Okay. Ethernet IP is going to bring in some of that name for you so you don't have to create an alias. What I did in the demo is I created an alias that directly represents that particular word that I'm reading. I could have very well created a DFB to do it. So switching over now, I'm going to show you the Ethernet IP DTM. I backed out of it too far. And in this DTM, I'm using Ethernet IP right here. And I gave it a name, and I gave it an address setting. And if you notice, I don't have anything else. Why? Because the EDS file automatically told me what information I wanted to retrieve from that switch. And it's as simple as adding in. I could come right here and add in another switch, add, come over here and pick Ethernet IP, scroll down my list and pick the appropriate switch that I'm looking for. Right here. And when I add this in, it automatically adds in the device. Now I'm connected online, so I'd have to do it offline. And I'm just going to say, I would give it a name. Okay. And now that switch is automatically going to be put in my system. And when I build it, so right here is where the switch automatically, the EDS file automatically tells me how much data I'm bringing in. It's bringing in the names of the data, and it's automatically setting up the request down here that you see to capture that data from this particular switch. It's managed automatically for you. I'm reading 32 words in, 32 words out from that device, and here are the individual settings that I can manage for that Ethernet IP device. And again, when I go in and look at the Ethernet IP device, that I'm looking at the switches, all of this is automatically created for you. I did not type in any name. This is all coming from the EDS file, okay? I could take this data and bring it into a derived function block if needed, but right now it's available directly to you from a variable. And I could come over here just like I did before, and I could come over here and add an alias, meaning create a variable name of your choice to use, but this is the name that I'm bringing the data in at. Did that answer the question for the gentleman or the person that asked it? Okay.
Yeah.
So now let's play around with the individual switch. I'm going to come in here and type HTTPS 192.168.3.109. And if everything goes according to plan, I get my password right here, and I changed the password as required. This is all HTML5, okay? So now I'm in my switch, and this is the main one that you saw a screen capture of. I'm showing all of the different port statuses. The only two ports that are not plugged in are port 1 and 2. That's my fiber optic port. I can change the switch name. It tells me the uptime has been 2 hours and 45 minutes, the current temperature, and this upper limit and lower limit, when these are exceeded, I'm going to trigger that alarm for you. On the network, you can go in and do your VLAN ID, your global. We support IP4 as well as IP6. We can get the IP address to the switch from local, BootP, or DHCP as the need arises for the application. IP6 is the same way. Out of band over USB if I'm doing some programming there. If you notice, I can turn off some of these capabilities. If I don't want to allow anybody the ability to plug in with a USB with the right credentials, we can block it. One of the questions we get is how do we update the firmware? It's done straight through the web page. Here's how we save the configuration to the non-volatile memory. And if you notice up here, it's telling me that I made some changes to my NVRAM. And if I come down here and hit save, you will notice that the icon that's blinking up top quits blinking. And there you go. And it's telling me that I saved it. The external memory, I do not have one plugged in, but if I did, it would identify that external memory so I could save it there. We get into the individual ports. The configuration. Jerry pointed out from a cybersecurity standpoint, the very first thing we can do is turn the port on or off. A lot of people for cybersecurity, if the port is not being used, I want to turn it off. I can also come in and tell it to automatically power down if I'm trying to conserve energy, or if I want to turn off a PPOE port if it's not being used. Automatic configuration. These switches, when you plug a cable in and you plug it into the M580, it's going to automatically negotiate the speed up to 1 gigabyte, depending on the switch that you have. If you have a system that does not synchronize, let's say you have an older device that you're trying to plug into, it's 10 meg as an example, and I plug it in and it never syncs up because the old protocol and the new protocol, it just cannot figure out which one to connect up to. I can come in here, turn off automatic configuration, and manually configure the port to a certain speed. We will automatically, if you don't change it, manual cable crossing. In the early days, you'd had to have a straight through cable or a crossover cable. I don't care which one you plug in with, as long as it's a valid Ethernet cable, it'll automatically cross the connection back to make the connection correct. We send a trap on link up or down. This trap goes to SNMP. So if I want every time somebody plugs into it or every time I disconnect, I will send this trap. Signal just does as the name implies. I got a whole bunch of switches in my cabinet, and I'm trying to figure out, one, which switch am I talking to? And by the way, which port is port 10? It's marked on the switch, but I could click signal and it'll show you. I can restart the switch. I can clear the statistics. I can reset the MAC address table, the ARP table. So sometimes you'll be doing that. Time. We support multiple time protocols. Right here, I don't have an NTP server, network time protocol server on the network. So I'm just going to say set it to my computer time. Simple network time, SNTP, simple network time protocol. I'm going to either be a client or a server. And if I'm a client, I'm going to tell it where the system is. And when I turn it on, I'm going to go request data from the NTP, and it's going to give me the time. Or I can be a server, meaning once I set the time in the switch, I can point my M580 to the switch and says, this is your NTP server, okay? Normally, most customers are going to have a NTP clock on their network that's tied to the satellite or tied to some kind of NTP service so that I can get a common time across all PLCs, all HMIs, all IEDs, and anything else inside your plant that needs to have time so that when I get an alarm, you're confident that that time matches what I'm looking at on my SCADA system as an example. Another time protocol is PTP protocol, precision time protocol. It's IEC 1588. Here's how I would set it up. And if you've ever played with this one, you know you got a boundary clock and a transparent clock that you have to set up. The last protocol we support is the 802.1AS. And that is a different protocol set up for time. And as you can see here, I got a lot more settings on this. This particular protocol is supposed to be a higher resolution than NTP, as an example. So we're going to come in and set this up, and then you have statistics on what's coming in, how much of a delay do I have, and so that's the network time. Then we get into network device security. You already saw me type in admin, and I'm the role of the administrator. I can come in here and add users and just give them the ability to look, but not change. I can tell them if you log in and you login attempts fail, I can log you out for 10 minutes or not let you log in. And then the password policy, love it or hate it, I can go define uppercase, lowercase, how many digits, how many special characters. So right now, the default is you have to have one of each, okay? This can be adapted to your particular company's requirement. Authentication lists, Radius servers and SSH, Telnet, web interface, I can turn those on and off. And then, so we're going to define how I can block somebody coming into the web page. If I don't have the right certificate, I would never make the connection. Lightweight directory app protocol. If I'm using that, I can come in and configure it, tell it where it's located, and then I will go to that LDAP and get the permissions whenever you log in and grant you the permissions that are allowed. You can put a banner text in, please contact tech support at this phone number if you're having any issues, so it allows you to modify the banner. We get into network security, and I'm not going to run through all of these. I'm just going to give you a quick overview. The port security, come in here and tell me how you want to block it. Auto disable, I want to send a trap. What's the trap interval? Static MAC addresses, last violating LAN, I send the trap. I can give you the details on it. If you're doing 802.1x, you got authentication. You're going to come in here and configure that for it. And we have a whole bunch of information on what's going on there. If you're using the Radius server, people will tell you how to configure that. Denial of service, I can come in and turn that on to tell me if I've got a packet problem above a certain amount, I can block it. DHCP snooping, there's a way to verify. You're going to come in and say, wait a minute, I need to verify the MAC. And of course, you can see configuration, statistics, and binding. IP source guard, I can go in and verify the MAC, meaning I'm only going to allow the NOC module that's in the rack right now to communicate to me. If I switch that NOC module to a new one, I'm going to have to come to the switch and modify the MAC address or tell it to relearn the MAC address. But once I tell it to remember that MAC, that's the only device that's going to communicate through the switch. Dynamic ARP inspection. This is to prevent it being spoofed. And you have the configuration. I have the rules that you're going to define. And again, we have statistics. Access control lists, IP4, I can assign the MAC or assign it to there. And then we get into the switching. And it's just more and more settings. Rate limiter to prevent a broadcast storm from taking down the network. I'm going to filter by the MAC address. And right now I've got it in learn mode. So that's how the switch makes the decision when a message comes in, it needs to go from port 1 to port 7. Remember, a switch does not broadcast a message to every port unless it's one of those messages like an ARP or a DHCP that's going to do it. But normal messaging, it's going to go port to port. And again, here, IGP snooping, we get down into quality of service. So now we're getting into defining how the switch is going to allow certain messages to have a higher priority. Queue management. And then if you get into virtual LANs, you're going to set up a virtual LAN. You're going to set up the global, the configuration. You're going to set up what ports belong to what LAN, and voice. If you normal Ethernet switches, I will not allow voice over VLAN mode automatically. You have to go turn it on. Jerry pointed out the redundancy. If I want to put these switches in a redundant configuration, we support MRP, hyperring, spanning tree protocol, link aggregation, link backup, and FuseNet. Some of these are particular protocols that are specific to Hirschman, like FuseNet and hyperring. Spanning tree and rapid spanning tree protocol are defined by the IEEE standard. In fact, on the Modicon Ethernet remote I/O drop, we use rapid spanning tree protocol to ensure that 50 millisecond recovery. And then, of course, we get into diagnostics, status, device status, and you tell me what you want to do for the diagnostic part. Do you want to be bothered with an email every time something happens? I can define that to what level I want to send it to. And then I get into loop protection. As Jerry pointed out, an unmanaged switch, if you plug it into a loop, you're going to create a broadcast storm because typically an unmanaged switch will not participate in a ring configuration. It may block the protocol that's coming through, but for the most part, if you're using rapid spanning tree, you want to have a managed switch. So I can come in here and define how many ports, what ports are involved in rapid spanning tree. We get down into some of the advanced settings. Here's where I'm going to set up your DHCP server. In other words, if you don't have one on the network, I want to go ahead and assign one. So now my Ethernet switch could be the one that's giving out the IP addresses if needed. And last but not least, we get into the industrial protocols, which you already saw the screen captures on those, and I have them turned on. And I don't have MS turned on, but I have Modbus TCP IP and Ethernet IP. And then the digital I/O module, when do I want it to operate, when do I want it to send a trap. And if you're old school and you just don't like the web page, you can do everything I've shown you in a command line interface. But I feel that the command line interface is being replaced by the HTML5 web pages. But if you've got it and you like the command line interface, you can go do that. That's all we had on it. That gives you a quick overview of the Modicon switches, how we integrate those into a Modicon M580. And Jerry, do we have any more questions that we need to answer?
Hi, Robert. Yeah, we do. Let's see. There was one question up here about hazardous locations. I know that our managed switches have an ATEX rating. I don't know if they go beyond that.
I believe the switches are Class 1, Division 2. That should be listed in the catalog, okay? And so that should be listed there, Class 1, Division 2, both UL and CSA.
Yeah. Is there a management software to mass configure switches?
Management software that will mass configure the switch, I am not sure.
I'm not either. Now, I think you stated that it's possible to export a configuration. Could that be imported into another web page or website for a different switch and used as a basis for its configuration and just change the IP address?
I didn't hear all of that one, Jerry. You were breaking up slightly.
Right. So can you export the configuration, a web configuration from the switch and use that on a different switch?
Yes. Now I understand your question. Yes, one of the options is you can save that configuration file off to your computer. That's what I did here. And I brought it back in. And the only thing I did was change the IP address and made a new configuration file. The one caution is if you're planning on doing that, remember that when you bring that configuration in the second time into a new switch, it is going to have a duplicate IP address. So when you bring it in, you're basically going to go in there and make sure that you not duplicate. You're going to bring it into a switch that's not connected to the same network, if you will.
Yeah, very often that would be the only configuration change you're making, I would guess.
Yeah.
Are switches viewable and configurable on Hirschmann's industrial high vision software? Now, that's a great question. I have just requested a download for that software. I haven't tried it myself. Do you know the answer to that, Robin?
I do not know the answer to that.
We're going to test that.
All right. So I want to give a big thanks to Jerry and Robert for hosting our presentation today and putting the time together to put the whole webinar together, quite frankly, and all this information. Thanks, everyone. This concludes our webinar. Thank you for joining, and we look forward to having another one in probably about 6 weeks from now. Thank you, everyone. Have a good day.